For 4,500 years, it stood silent, hiding its secrets behind millions of tons of limestone. The most studied structure in human history, archaeologists have crawled through every known passage, mapped every chamber, measured every block. We thought we knew everything about the Great Pyramid of Giza. We were wrong. November 2nd, 2017. Scientists announced something impossible. Something that shouldn't exist. Deep inside the pyramid, in a place no human has entered in millennia, there's a void. Not a small cavity. Not a construction gap. A massive hidden space. At least 30 meters long. Possibly a chamber. Possibly a corridor. Possibly something we can't even imagine. And no one knows what's inside. This discovery uses particles from outer space to see through solid stone. It combines ancient Egyptian engineering with cutting-edge particle physics. And it raises questions we thought were settled centuries ago. Questions like, did the pyramid builders leave something behind? Is there a hidden chamber we've never found? What else might be concealed inside the world's most famous monument? And perhaps most disturbing, if we missed this, what else have we missed? Welcome to the void, the space that shouldn't exist, the chamber that might rewrite everything we know about ancient Egypt. To understand why this discovery is so shocking, you need to understand what the Great Pyramid is. The Great Pyramid of Giza, also called Khufu's Pyramid, after the pharaoh who commissioned it. Built around 2560 BC, 4,500 years ago. The numbers are staggering. 2.3 million stone blocks, each weighing an average of 2.5 tons. Some weighing up to 80 tons. 146 meters tall when completed, the tallest human-made structure on Earth for 3,800 years. Aligned to true north with an accuracy of 1/15 of a degree. Built in approximately 20 years, meaning workers had to place a block every 2 to 3 minutes, 24 hours a day, for 2 decades. Estimated 100,000 workers, engineers, stonemasons, laborers, support staff. This wasn't just construction. This was a national mobilization, a technological feat that pushed ancient civilization to its limits. Inside, we know of several passages and chambers. The descending passage, carved into bedrock, leading to the subterranean chamber. The ascending passage, rising up into the pyramid's interior. The Grand Gallery, a soaring corbelled corridor, over 8 meters high and 47 meters long. The Queen's Chamber, a misnomer. We don't know its actual purpose. The King's Chamber, where Khufu's sarcophagus sits, built from solid granite blocks. The relieving chambers, 5 compartments above the King's Chamber, designed to distribute the pyramid's weight. For centuries, explorers have searched for more. Secret chambers, hidden passages, the burial treasures that were supposedly sealed inside. Arab Caliph Al-Ma'mun tunneled into the pyramid in 820 AD, searching for legendary treasure rooms. He found nothing but empty chambers. European explorers in the 1800s used gunpowder to blast through walls, convinced there must be more rooms. They found construction gaps and air shafts. No hidden chambers. Modern archaeologists have used ground-penetrating radar, seismic surveys, even drilling through stones. Still nothing. By the 21st century, scholarly consensus emerged. We've found everything. The Great Pyramid has no more secrets. Then, in 2015, a team of scientists proposed something audacious. What if we could see through the pyramid? Without touching it, without drilling, without damaging anything. What if we used particles from space itself to create an X-ray of the entire structure? They called it the ScanPyramids project. And what it discovered changed everything. 2015. An international team of scientists, engineers, and Egyptologists launches the ScanPyramids mission. The goal: use non-invasive technology to scan the interior of multiple pyramids at Giza, searching for unknown voids, chambers, or structural features. The team includes Egyptian researchers from Cairo University and the Heritage Innovation Preservation Institute, Japanese particle physicists from Nagoya University and KEK, High Energy Accelerator Research Organization, French engineers from CEA, French Alternative Energies and Atomic Energy Commission, Canadian experts in thermography from Laval University. They bring three main technologies: infrared thermography, detecting temperature differences in the pyramid stones. Different densities and voids create thermal signatures. Early scans immediately reveal anomalies. Certain stones are cooler than others. Certain areas show unexpected heat patterns. Something is different about the pyramid's internal structure. But thermography can only suggest possibilities. To truly see inside, they need something more powerful. 3D laser scanning, creating millimeter-precise digital models of all passages and chambers. This provides baseline data. Now they know exactly where everything we've already discovered is positioned. But the revolutionary technology, the one that will change everything, is the third method: muon radiography, particle physics applied to archaeology, using cosmic rays from space to X-ray the pyramid. This is where science fiction becomes science fact. Between 2015 and 2017, the team places multiple muon detectors inside known chambers of the Great Pyramid. Inside the Queen's Chamber at the bottom of the descending passage and the Grand Gallery. Multiple external positions for triangulation. Each detector is essentially a sophisticated camera that sees through stone using particles from space. The detectors sit silently, watching, recording, counting particles for months. And slowly, an image emerges. An image of the pyramid's interior, not from electromagnetic waves like X-rays, from cosmic rays, from particles that have traveled through the vacuum of space, through Earth's atmosphere, through millions of tons of stone, and through something else, something hollow, something empty, something that shouldn't be there, a void. Before we reveal exactly what they found, I need you to subscribe to this channel right now, because we're about to dive into particle physics, ancient engineering, and one of the biggest archaeological discoveries of the 21st century. And drop a comment. If you could explore any hidden chamber in history, which would you choose? The Pyramid Void? Tutankhamun's undiscovered rooms? Qin Shi Huang's tomb? Now, let me explain how we can see through millions of tons of stone using particles from space. Muon radiography sounds like science fiction, but it's based on simple, proven physics. Here's how it works. Every second, Earth is bombarded by cosmic rays, high-energy particles from space. They originate from supernovae, pulsars, black holes, and other violent cosmic events. When these cosmic rays hit Earth's upper atmosphere, they collide with atoms, nitrogen, oxygen, and create showers of secondary particles. One of those secondary particles is the muon. Muons are subatomic particles, similar to electrons but about 200 times heavier. They're unstable. They decay quickly, lasting only microseconds. But they're also incredibly fast, traveling at near light speed. So even though they decay quickly, they can travel significant distances before disappearing. Approximately 10,000 muons per square meter per minute rain down on Earth's surface. They're passing through you right now, through this building, through everything. They can penetrate deep underground, through mountains, through rock, through pyramids. Here's the key principle. Dense matter absorbs more muons than empty space. When a muon passes through solid stone, there's a chance it will interact with atoms and be absorbed or deflected. The denser the stone, the higher the absorption rate. But when a muon passes through empty space, air, a cavity, a void, it passes straight through. No absorption. So here's what the ScanPyramids team did. Step 1. Place muon detectors inside known chambers of the pyramid. These detectors count how many muons arrive from different directions. Step 2. Wait. For months, let cosmic rays naturally bombard the pyramid from all angles as Earth rotates. Step 3. Analyze the data. If fewer muons arrive from a certain direction, that means they passed through dense stone and were absorbed. If more muons arrive from a direction, that means they passed through something less dense. Step 4. Create a 3D map. By combining data from multiple detectors at different positions, you can triangulate exactly where the less dense areas are. Step 5. Compare with known chambers. You already know where passages and rooms exist. Subtract those from the data. Step 6. Whatever remains is unknown. And something remained. The detectors in the Queen's chamber showed an excess of muons arriving from above and in front. More muons than should be possible if solid stone filled that space. The detectors at the pyramid's base confirmed it from a different angle. Triangulation matched. There was a void, a big void, at least 30 meters long, positioned above the Grand Gallery, roughly parallel to it. A space that no modern human has ever entered, that no archaeological survey has ever detected. That has been sealed for 4,500 years. On November 2, 2017, the team published their findings in the journal Nature, one of the most prestigious scientific publications in the world. The title, Discovery of a Big Void in Khufu's Pyramid by Observation of Cosmic Ray Muons. The scientific community reacted with shock, excitement, and intense debate. Because this void, it raises more questions than it answers. So what exactly did they find? Let's look at the specifics. According to the published research, the void has these characteristics: minimum length, 30 meters, roughly the length of the Queen's chamber below it. Cross-sectional area, similar to the Grand Gallery, possibly 8 meters high, 2 meters wide. Location. Above the Grand Gallery, roughly 40 to 50 meters above ground level, deep inside the pyramid's core. Orientation. Appears to run parallel to the Grand Gallery, possibly with a similar ascending angle. Detection confidence. Multiple independent detector systems confirmed it. Statistical significance of 5 sigma, meaning there's less than a 1 in 3.5 million chance it's a false positive. This isn't speculation. This is peer-reviewed scientific measurement. But what is it? The researchers are careful not to speculate wildly. But they propose several possibilities. Theory 1. A construction chamber or corridor. When building the pyramid, workers might have created internal ramps or temporary spaces to move materials up to higher levels. Some of these spaces might have been intentionally left void rather than filled in. The void's position above the Grand Gallery could indicate it served a similar function, a corridor for moving the massive granite blocks used in the King's chamber. But this raises questions. Why leave it empty? Why not fill it with rubble blocks like other construction gaps? And why does it appear so precisely aligned and large? Theory 2. A structural stress relief feature. We know the pyramid has 5 relieving chambers above the King's chamber, designed to distribute the pyramid's massive weight and prevent the ceiling from collapsing. Perhaps the big void serves a similar purpose. A deliberate empty space that prevents stress from cracking the Grand Gallery ceiling. Engineering analysis supports this. The void's position would effectively redirect compressive forces around the Grand Gallery, protecting this crucial architectural feature. Theory 3. A hidden chamber with unknown purpose. This is the possibility that captures imaginations. What if the void is an intentionally sealed chamber? A room that was meant to remain hidden? Ancient Egyptian pyramid texts mention multiple chambers in royal tombs. Some were decoys, some held treasures, some served ritual purposes we still don't understand. Could this void contain artifacts, religious objects, perhaps even a burial chamber we never knew existed? Or is it something else entirely? Something we can't even imagine because we don't understand the pyramid builders' intentions. Here's what the void is not, despite sensational headlines. It's not a secret treasure chamber. We have no evidence of contents. It's not a lost burial room. The King's chamber remains the most likely burial location. It's not proof of aliens. Every aspect is consistent with ancient Egyptian engineering. It's not accessible. There are no known passages leading to it. Simply a void, an empty space, detected through particle physics, confirmed through multiple methods. But that's precisely what makes it so fascinating. Not all Egyptologists accepted the discovery immediately. Some raised valid concerns. Skeptics argued, muon radiography might be detecting construction irregularities, not a single large void. Perhaps multiple small gaps create the illusion of one big space. The team responded, multiple detector positions confirm a continuous void. The statistical analysis rules out scattered small voids. Skeptics argued, without physical access, we can't confirm what's actually there. It might be rubble-filled, not truly empty. The team responded, muon flux clearly indicates lower density than solid stone. Whether completely empty or partially filled, it's structurally different from surrounding areas. Skeptics argued, we should drill or use fiber optic cameras to investigate. Egyptian authorities responded, absolutely not. No invasive investigation will be permitted without exhaustive non-invasive study first. This tension between scientific curiosity and preservation ethics defines modern archaeology. We can see through stone with cosmic rays, but that doesn't mean we should drill through 4,500-year-old monuments. If you're as fascinated by this cosmic X-ray technology as I am, hit that like button and comment your answer to this. Should we explore the void with cameras and robots, or leave it sealed and mysterious? There's no right answer, but I want to hear your reasoning. Now, let's talk about what this means for the future. The Big Void discovery isn't just about one chamber in one pyramid. It represents a revolution in how we study ancient structures. For centuries, archaeology was destructive by necessity. To learn what was inside a tomb, you had to open it. To understand a building structure, you had to excavate. But technologies like muon radiography change everything. We now have an arsenal of non-invasive tools. LiDAR light detection and ranging reveals entire lost cities beneath jungle canopy without clearing a single tree. Ground-penetrating radar detects buried structures without excavation. Satellite thermal imaging finds archaeological sites from space by detecting subtle temperature differences. Cosmic ray muon tomography X-rays massive structures using particles from space. Environmental DNA analysis identifies what lived in an area without finding bones or fossils. These technologies are rewriting history. Lost cities are being found. Unknown chambers revealed. Ancient landscapes reconstructed. Since the ScanPyramids success, muon radiography has been proposed or applied to other pyramids, scanning Khafre's and Menkaur's pyramids at Giza for unknown voids, Japanese burial mounds, Khofun tombs that have never been opened, Mayan pyramids, detecting chambers inside temples in Central America, volcanoes, mapping magma chambers for eruption prediction, nuclear reactors, inspecting damage at Fukushima without human exposure to radiation. The same technology that revealed a 4,500-year-old void helps monitor active volcanoes and damaged reactors. Particle physics meets archaeology. Space science meets ancient history. But this technology raises profound ethical questions. If we can see through stone walls, should we? If we can detect sealed chambers, must we open them? If ancient builders deliberately hid something, do we have the right to reveal it? Egyptian authorities have been cautious. They approved the scanning but have prohibited any invasive investigation of the void without extensive international consultation. Some Egyptologists argue we should never open it. The void has remained sealed for 4,500 years. Opening it would be disrespectful to the builder's intentions and risk damaging whatever might be inside. Others argue we have a responsibility to investigate. Knowledge is humanity's heritage. If we have the tools to learn, we must use them. There's no easy answer. Current proposals for investigating the void include additional muon scans from different positions to refine the 3D model. Microdrilling, inserting fiber optic cameras through millimeter-wide holes to visualize the interior without causing structural damage. Robotic exploration, if a natural passage to the void exists, using small robots to investigate. Advanced sensing, using ground-penetrating radar, seismic tomography, and other techniques to gather more data before any physical intrusion. As of 2024, no invasive investigation has been approved. The void remains a void, known but unexplored, detected but sealed. Schrödinger's chamber, both full of mysteries and empty of answers. So what have we learned? The Great Pyramid, the most studied structure in human history, still has secrets. After 4,500 years, after centuries of exploration, after every modern technology we could throw at it, it still surprises us. We know there's a void, at least 30 meters long, deep in the pyramid's core, detected by particles from space, confirmed by multiple independent measurements. We know it's real. This isn't speculation or wishful thinking. It's peer-reviewed physics published in Nature. But we don't know why it exists. Construction feature? Stress relief? Hidden chamber? Something we haven't imagined. What's inside? Empty air? Rubble? Artifacts? Nothing. How to access it? Is there a sealed passage? Was it always isolated? What the builders intended? Was it deliberate? Accidental? Structural necessity? What else we've missed? If this void went undetected for 4,500 years, what else is hidden? The discovery of the big void teaches us something humbling. No matter how much we know, there's always more to learn. We've mapped the human genome. We've photographed black holes. We've sent robots to Mars. And yet a structure built by people without computers, without advanced mathematics as we know it, without modern tools, still conceals mysteries we can't solve. Somewhere around 2560 BC, workers built this void into the pyramid. Whether by design or necessity, they created a space that would remain hidden for 4,500 years. They never imagined that particles from exploding stars would one day reveal their work. They never conceived of muons, detectors, or particle physics. But they built something so sophisticated, so precisely engineered, that it required cosmic rays to fully understand it. That's not primitive. That's genius. The void isn't just empty space inside a pyramid. It's a reminder that the past isn't fully known, that ancient peoples were far more sophisticated than we often credit, that mystery still exists in the world, and that sometimes the most profound discoveries come not from digging, but from listening. Listening to particles from space, whispers from the cosmos, echoes of ancient ambition preserved in stone. The Great Pyramid has stood for 4,500 years. It will likely stand for 4,500 more. And somewhere inside it, in a space detected but not entered, the void waits, waiting to reveal its secrets when we're ready, when we're wise enough, if we ever are. If this journey into cosmic archaeology blew your mind, subscribe to this channel. We explore mysteries where cutting-edge science meets ancient history. Hit that like button. It helps this content reach more curious minds. And here's your final mission. Comment with your prediction. What do you think is inside the void? Engineering, space, hidden chamber, something else? Give me your best evidence-based theory. And one more question. Should we open it or leave it sealed? Defend your answer. I'll see you in the next investigation, where science illuminates darkness and mysteries refuse to stay buried. Until then, look up at the stars. Some of those particles passing through you right now, they've been through the Great Pyramid. They know what's in the void. They're just not telling.